Today we will talk on natural fats and oil and plasticity. This is Jayati Chattopadhyay from Department of Food Technology, Techno India. Now we all know that fats and oil are abundantly present in nature in two sources. One is plant source, where oilseed nuts and fruits, they have a very high fat content, and second is animal source, where milk, egg, poultry meat or animal carcass, they are the potent source of fats. Now plant source, that is plant oil, they possess some definite properties. Mainly, they are liquid in nature. Their melting point is lower than ambient temperature, so they are always in liquid phase at room temperature, and they have very high degree of unsaturation, that is unsaturated fatty acids are majorly present in this oil, and the fatty acid distribution are even. So normally all these vegetable oils are similar in physical characteristics. But when it comes to animal fat, the properties are just opposite. That is, they occur mostly in solid phase. Melting point is higher than room temperature. It is mainly because of high percentage of saturated fatty acid present in animal fat, and so often the phase separation is observed in this animal fat. Today our talk will mainly be concentrated on how these naturally available plants and animal fats can be processed to a plastic fat. That is, mainly we will elaborate on the way to plasticity. Now, plastic fat is basically a blend of two phases of fat, that is, one is fat in solid phase, another is fat or oil in liquid phase. And the main conditions of plasticity is that the liquid phase should be interlocked in the dispersion of the solid crystals. Here we have shown a microstructure of this plastic fat. Main properties of plastic fat is this should be non-greasy solid at refrigerated temperature. This should have a definite glass transition temperature beyond which it will become a viscoplastic dispersion. So that means when it will come in plastic phase, it will just cross its glass transition temperature. And in the plastic phase, it should exhibit the flow behavior beyond the critical stress. Now, to transform the naturally available plants or animal oil or fat to this plastic fat, the basic ingredients which are required, this is the solid fat blend and the liquid oil. That means plasticity cannot be incorporated only in the liquid oil alone, unless and until solid fat is blended in this liquid oil in a definite proportion. So this blending has some challenges that we will discuss later on. Now as a solid fat, we can use animal fat like oleostearine or tallow, or we can use vegetable fat after proper processing, that is hydrogenated, fractionated or interesterified fat. And as liquid oil, normally those oil which has substantial amount of saturation, that is cottonseed oil, palm oil or sesame oil, they are mainly used as the liquid oil base for this plastic fat. Now, what are the challenges in blending of two fatty phase. One is solid phase, another is liquid phase. The main challenge is that the blended fat must have sufficient solid characteristics. That means the solid fat must be incorporated in the liquid fat in substantial proportion so that its solid characteristics can be enhanced or improved. And the second challenge is the solid liquid blend must have a definite melting point range. That is, the melting point range can be wide or can be sharp, but it should be very definite. Now, the next is after a thorough blending of this solid fat and this liquid oil, the whole fatty phase is allowed to be cooled so that the solid fat will be gradually crystallized in the small dispersible form. Now the crystal size, shape and structure are are some major factors to guide the final texture of this plastic fat. And after the full crystallization phase is over, the the crystals with this liquid phase, this particular blend is then subjected to kneading operation where the fat crystals are uniformly dispersed in the blend matrix. This uniform dispersion is very essential to attain the microstructure of the plastic fat, and ultimately here we have shown a definite example of plastic fat. This can be butter or margarine pieces where the plasticity has been incorporated in the natural fats or oil. The blending operation of this solid fat and the liquid oil must conform to certain feasibility. That is, we cannot just blend two solid fatty phase or two liquid phase or any kind of solid or liquid phase. Before blending, it should be ensured that the final blend should be spreadable at room temperature. That means the raw material melting point, the raw material or the ingredients melting point should be in such a range so that after blending it come to that plastic phase and it is spreadable at room temperature. This spreadability can be measured by the peak force by penetrometer probe in a texture meter, and the peak force should conform to a certain specific range to have a proper spreadable texture. Next thing we must remember before blending of two phases, that is the source of this solid and liquid fat or oil should be adequately available in nature, so that we cannot just blend very non-conventional oil. This actually otherwise the blending operation will be not feasible. And the last is, other than availability, the cost of the solid fat also guides the feasibility of blending. That means the vegetable oil, when it is processed like interesterified or fractionated to make the solid vegetable fat, the more and more processing the vegetable oil will undergo, its cost will also becoming very high. So we need to also balance these optimum processing stages so that the cost of the solid fat will not be very high. So the cost, availability and the plastic property of the blend are the very major factors or the key factors to conform to the feasibility of blending. So finally, we learned that how this vegetable oil can be processed to become make the vegetable fat, and how this vegetable fat or animal fat can be blended effectively with vegetable liquid oil and uh, crystallized and kneaded effectively to ultimately get the texture of plastic fat. Thank you.